talk about the unit circle, and here are the objectives. We will convert angle measures between degrees and radians, and this is something you've done previously in your past math class. And we are also going to use that information to help us find the values of the trigonometric functions on a unit circle. Okay, let's start. So when you talk about a unit circle, right, there are two specific measurements that we will be using. One of the units is what you call a radian, and it is a unit of angle measure, much like a degree is, but because it's a radian, the measurement is based on what you call the arc length. Now, what's the arc length? Okay, so let me visually show you what the arc length is. On a circle, the arc length is just basically this edge right here. That is an arc length. Now, an arc length could be longer than that, shorter than that. It really depends how wide an angle opens. Okay, and this is a measurement we call a radian. So if you remember in the past when you learned about the circumference of a circle, you remember using r, the radius, and the formula is said to be 2 pi r. Well, here's a really good example or visual of that. So we say that theta here is about a radian, and if you were to repeat this, okay, so if you were to draw them out across the circle, you end up producing 2 pi r. Okay, so let's take a look at the given. So once again, you talk about the angles in standard form. The blue one right here represents pi, as you remember on your circle, right? Half of a circle is pi, or otherwise pi radians, okay? Or otherwise it measures 180 degrees. But at the same time, okay, that's half a circle. If you were to complete a rotation, a complete circle, you would say that that measures 360 degrees on the red graph, or we can say it's about 2 pi radians. Okay, and so that's why we said it's 2 pi times r. Okay, please do not confuse r with radians. Radians is a unit of measurement, much like your degrees, your meters, and etc. Okay, all right, so let's use that information as we go forward. So to convert angle measures, there are two specific ways. You're either converting from degrees to radians, and in order to do that, we multiply the given measurement by pi radians over 180 degrees, allowing us to cancel out the degree unit, changing it to radians. In the same manner, you have the conversion from radians to degrees, where you multiply the given by 180 degrees over pi radians, this time eliminating pi and radians, so that the unit is in degrees. So let's take a look at how we are going to perform those steps. All right, let's start over here in part A. So to convert negative 45 degrees from degrees to radians, all right, we will say that we will multiply the given, negative 45 degrees, all right, will be multiplied by, right here, pi radians. Okay, so you can use rad, it's the same as radians, over 180 degrees. And your objective is to simplify this without leaving a decimal. So you need to think of your simplest form. How do you express fractions in its simplest form? Okay, all right, so let's see. 45 actually goes into 180 about how many times? Yep, think about it. Exactly, it goes in about 4 times, or actually exactly 4 times. So we're saying that this is divisible by 4. Okay, this is just the 1 now. So then simplifying further, we say that negative 45 degrees is the same as negative pi radians over 4, or negative pi over 4 radians. And this is your converted value for negative 45 degrees. In the same manner, if we were to convert 5 pi over 6 radians to degrees, we would then use 5 pi over 6 and multiply it by 180 degrees over pi radians. Okay, so remembering that you want to place whatever you want to cancel out in the denominator. So that's how you know which formula to use. What are you trying to eliminate? For example, this right here, part B, you're trying to eliminate pi. So would you put pi in the numerator? No, you won't. You'll have to put it in the denominator. And pi always goes along with your unit radians. So from here, you can eliminate pi, right? Pi radians. We forgot to put radians. That's eliminated, thus your unit is now in degrees. So 180, you can simplify further, whichever way you prefer, but 180 degrees is divisible by 6. So this will leave me with 30 degrees, which now, okay, so right now this is what we have. We have 5, which needs to be multiplied by 30 degrees. So really, this converted in the degree measurement will give you 150 degrees. Okay, so that's how you can convert from degrees to radians. In the next page, you'll have the opportunity to practice doing those. So once you see the questions, go ahead and pause the video and try those out before you proceed. Convert each measure from degrees to radians or from radians to degrees, whichever is given to you. Go ahead and pause the video right now, and I will continue in a second. So to convert the measurement 80 degrees, we are going to take a look at these steps and show the solutions. So for 80 degrees, we can go ahead and do the following. I will multiply it by pi radians over 180 degrees, simplifying what I can so we can end up with 4 pi over 9. Now in radian units. In the next one, 2 pi over 9, this time you have a unit in radians. You're converting it to degrees. So let's multiply that by the following. All right, so let's remove this. All right, like so. So you're going to multiply it by 180 degrees over pi radians. Notice how you can eliminate a few things, simplifying. 180 divided by 9, you'll get a 20, which you need to multiply by 2, therefore 40 degrees. Again, you can stop the video, pause it at some point, and take a closer look at the solutions. The next one is a negative angle measure, and that's okay. Let's take a look at how it's converted. We multiply it by pi radians over 180 degrees, leaving our unit in radians of negative pi over 5. In the same manner, the last one, we convert this into degrees, multiplying and simplifying 180 degrees multiplied by 4, giving us the 720. Okay, so take a second to review your answers. Make sure you're simplifying correctly and carefully, making sure you find the simplest form. Let's go forward. All right, so we've been talking about conversions and how we're working on a unit circle. Now we're actually going to discuss further about the unit circle. So a unit circle, just by the name itself, is called a unit circle, all right, because the radius is 1 unit, okay? Meaning, take a look at, there's infinitely many radius or radii, right, on a circle. So saying that its measure is 1 unit, that's the length and it's consistent all throughout. So for every point on the unit circle, okay, the value of the radius r is going to be 1. So let's take a closer look at the given. Okay, let's recall a few things. Your unit circle is actually divided into 4 parts. You have quadrant 1, where your signs for x and y, the x and y coordinates, are both positive. In quadrant 2, where the signs are negative, positive, based on the coordinates. In quadrant 3, where they're both negative. And in quadrant 4, where the x value is positive, but the y value is negative. Okay, so what does that really mean to us? We know that the radius is 1. All right, we understand that. Now, what do these numbers represent? Remember how we just converted from degrees to radians and radians to degrees? What the unit circle is showing us is this. For every specific degree measure, it has a corresponding radian measure. For example, the 30-degree measure corresponds to a pi over 6 radian measure. In the same manner, okay, 120 degrees corresponds to a 2 pi over 3 radian measure, and so on and so forth. So we figured out the degrees as listed on our unit circle, as well as your radian measurements. Now, what do these values out here tell you? What are they? What do they represent, right? If you remember back to your previous lesson, 10-2, okay, we discussed about the trigonometric ratios of right triangles, where you had your 30, 60, 90, and 45, 45, 90 triangle, where you had specific values. For example, if you would recall, sine 30 degrees is 1/2. Okay, so that's the idea that we're trying to connect to our unit circle. That's actually how the sine 30-degree value was obtained. Okay, so let's take a look at the given. So sine 30 degrees we said is 1/2. So take a look at this. This is the 30-degree angle. If you look at the coordinates, there's 1/2 right there. Now, why is sine 30 degrees 1/2? All right, so let's elaborate a little bit more. Let's illustrate that over here. So if we were to take out that angle measure, it would look something similar to this. Okay, close enough, not exactly, right? Something like this. So this is us dropping down a straight vertical line all to the x-axis. Okay, thus the triangle we produce. Where this is theta, this is your 30-degree angle. All right, so we're asking ourselves, well, why is this root 3/2, comma 1/2? And that's the coordinate of that point. That's point P, or x comma y, right? All right, so going back, what do you remember about the trigonometric ratio? When you think of your 30, 60, 90 triangle, you think back to the ratio. Okay, so that's how we got these values. In fact, the hypotenuse right here, which is also this length, okay, you remember that that's actually your radius. And we said that the radius measures 1. Okay, so, and it's the same all throughout the circle, even if your right triangle will be produced from this point. The hypotenuse, the radius, remains to be 1. That's why it's called a unit circle. And notice how the values are very repetitive, okay, specifically for corresponding multiples, okay, and their signs change depending on which quadrant they're on. So if it's a unit circle, okay, take a look at this. On a 90-degree angle, okay, that this forms, notice how the point right here for a 90-degree angle, it corresponds to a pi/2 measurement, like so, where its coordinate point is located at 0, 1. Why 0, 1? Where did that come from? So if you were to look at this thinking of your coordinate plane, wouldn't this be a length of 1? Thus the y value being a 1? And because you're looking for the x value, if this is the point of origin, this point right here is a 0. That's why the coordinate or the location for a 90-degree point right there is 0, 1. In the same manner, for 180 degrees or pi, okay, it will be a -1, 0, and a 270-degree measure, or 3 pi/2, is a 0, -1. And these are further concepts that we will continue to discuss. I encourage you to, if you can, and you have a printer, to generate a copy. Otherwise, you can create one in your notebook and list them down. It really, really helps to know your measurements. Okay, so let's see how we're going to actually incorporate this in the next few examples. All right, so we're actually going to use the unit circle right now to find the exact value of the given trigonometric functions. Let's look at cosine 210 degrees. So we're looking for the measurement that's a 210-degree angle. So let's go back. I'm going to backtrack to the other page. Okay, I'm going to clear this out so we can really see your unit circle. All right, so we're looking for a 210-degree measure, starting from the initial side, standard rotation, right? Positive rotation. I'm going all the way to the left, going past 180 degrees, and there's my 210-degree measurement. However, we're instructed to find cosine. So if that's the 210-degree measure, and these are the given coordinate points, your cosine will be represented by your x coordinate. Meanwhile, the y value will be represented by the sine value, or the y value. So we're really just using -√3/2. And just like that, you found cosine 210 degrees. Okay, so you need to use your unit circle. You need to know how you're reading it. That's why we started from identifying the initial and terminal points or ends so we know exactly which way you're rotating. Are you going clockwise or are you going counterclockwise? Okay. All right, so let's look at the tangent of 5 pi over 3. All right, so 5 pi over 3, let's look for that. What you know right now is that tangent theta, no matter what happens, is the opposite measure over the adjacent. But you also know that this refers to using the y value and dividing it by the x, or dividing the sine value by the cosine value. Okay, so let's go back. 5 pi over 3. Okay, so here's our unit circle. Let's locate 5 pi over 3. So to give you some idea, we will discuss this further. When you say that the circle is divided into parts, 5 pi over 3 actually is telling you this. Okay, ready? It's telling you that half of the circle, half of the circle is actually divided into 3 parts. Meaning this first part right here is pi over 3. That's why the denominator is 3. It's divided into 3 parts. This right here is 2 pi over 3. Therefore, on this horizontal point, it's a 3 pi over 3, or just pi. What do you know? It's the same thing. And in the meantime, when you continue on to the other half, it's also divided into 3 parts. Continuing, so this is 3 pi over 3. This one will be 4 pi over 3, 5 pi over 3, and on the last point right here where it becomes 6 pi over 3, which you can simplify into 2 pi. Isn't a full rotation 2 pi anyway? So that's the whole concept behind it, right? Super cool. All right, so let's go back. We're finding 5 pi over 3. 5 pi over 3 found out is right here at the bottom, equivalent to 300 degrees. So we're looking for tangent. We need the x and the y value. Okay, take note. Okay, so let's bring you back to the other page. We're going to now divide the values we were given. 5 pi over 3, where your y value is, or sine value is negative root 3 over 2. Dividing it by 1/2. Okay, remember to simplify your fractions. You do negative root 3 over 2 and multiply by the denominator's reciprocal, like so. And really, tangent 5 pi over 3 will simplify into negative root 3. And that's how you can find the trigonometric function that's being asked from you at the time. On the next page, you'll have an opportunity to practice. So once again, pause the video at any point and give yourself some time to work on these. All right, if you're ready, here we go. So we're going to use a unit circle to find the exact value of each given trigonometric function. So to find sine 315 degrees, again, if you're a visual learner, you can illustrate it, refer back to your unit circle. This is what I have. I found out that 315 degrees is about right here on its terminal site, where I'm actually checking that this is the coordinate we're given, but because I'm looking for a sine, I'm only looking at the y value. It should be a negative because I'm in quadrant 4, and that's sine 315 degrees. Let's move on to the next one. You have tangent 180 degrees, or tangent of 180 degrees. And if you remember, tangent 180 degrees is actually half of your circle, or it's the opening of a semicircle. So let's take a look at this. Remember that this location will produce negative 1, 0 as the coordinate, where tangent is where you have to divide the y value by the x value. So 0 over negative 1 will generate a 0. So tangent of 180 degrees is 0. Okay, all right, the next example, cosine 4 pi over 3. Okay, so remember 4 pi over 3 where the denominator is 3, that means half of a circle was cut into 3 parts, thus the whole circle was really cut into 6. Okay, 4 pi over 3 should end up on which quadrant? Yup, it should end up on the 3rd quadrant like so. Alright, so I found out that it's right here, referring back to your unit circle. Okay, this is just a general sketch, so you know where to find them. Because it's right here, and I'm looking for cosine in the 3rd quadrant, the sign for cosine, it's interesting, the sign should be a negative value. or we should find a negative value. And because these are the coordinate points, you take the x, because you're looking for cosine. In fact, it is negative 1/2. And that's how you can continue to use your unit circle. All right, let's go forward. Now, if you remember in section 2, we also had an opportunity to discuss about reference angles. Okay, do you guys remember what a reference angle is? Okay, think back a little bit. Reference angles, yup, aren't those the values that need to be acute and positive? Yes, you're exactly right. These are very special. You see, reference angles can be used in order to find and evaluate the other trigonometric functions. Really, you don't need to memorize the entire unit circle. You can if you want, if that's a choice you want to take. But just by using reference angles in quadrant 1 specifically, this will really help you simplify things or expressions and equations in the future. So here are some steps and tips to help you use the reference angles. So step 1, determine the measure of a given reference angle like we did before, and then use quadrant 1 and identify the corresponding sine, cosine, and tangent values. And of course, step 3, actually determine which quadrant the point will be on so that you can adjust the signs, whether it's positive or negative. Okay, so let's see what that means. Those are 3 steps we will continue to use all throughout. So we talked about using quadrant 1 right here. Okay, so I can make this a little bit bigger for you so you can see it. So we're going to refer to the first quadrant. These are actually really the only reference angle measures that you will find if you were referring to the measures in a unit circle. Okay, and these are super important. They're very repetitive, like we said. The only thing that's changing are their signs, depending on which quadrant you find your terminal side on. Okay, so use a reference angle to find the exact value of the sine, cosine, and tangent function of a 225-degree measurement. All right, so let's look at that. So first, find the measure of the reference angle. Okay, so illustrating, you'll find out that 225 degrees has a terminal side in the third quadrant. And when you have a discussion about reference angles, okay, we bring up the question of, well, how wide is the opening from the x-axis? Okay, so in this case, we're referring to 180-degree measure right here. How far is 225 from 180 degrees? And it appears that it's 45 degrees away. All right, so now we know this information. That's the reference angle. Now, how can we incorporate that to identifying sine, cosine, and tangent? Here's how. All right, so that was step 1. Step 2, we're going to use the reference angle to evaluate 225 degrees. Here's how. So we're using sine 45 degrees. What do you know about sine 45 degrees? Go back over here. In quadrant 1, we were given the following coordinates. Okay, and you're going to use these values, where sine 45 degrees is root 2 over 2, the y coordinate. However, remember you're in the third quadrant, so you need to check what should the sign be of any point in the third quadrant. Yep, it should be a negative sign. So that's why in step 3 it says adjust the signs if needed. And we said it's in quadrant 3, therefore sine 225 degrees should be a negative value. Super cool. So again, you only do this if and when you don't have a unit circle, but otherwise if you have access to it, then going through these steps won't be as necessary. Okay, but it does help a lot. It saves you time. Okay, moving on. If we were to find the cosine measurement of 225 degrees, using the reference angle, once again, you have root 2 over 2. However, considering you're in the third quadrant, any x-coordinate in the third quadrant must be also negative, correct? And on the very last note, for tangent 45 degrees, tangent means to divide your y value over the x value. So think about this. What would happen if you divided these two? You would get a positive 1. However, for a tangent function, right, you're going to divide them. So take a look at the actual adjustments that we need to produce. If they're both negative, they still end up dividing into a positive value anyway. So that's how you can check that you're doing it right. Confirm by checking every single step whenever you can. All right, so again, you can pause the video at any time, backtrack a little bit, and replay it whichever point you need to. All right, let's go and bring you to the next page. All right, so right now I have a few examples for you to try out, and these are the last 3 questions that we will work on in this video. We are going to explore the following. So use a reference angle to find the exact value for the given. Again, you can pause at any point. I just realized we're not done. We have one more after this slide. All right, so no, this is the last slide. You're right, this is the last slide. All right, so use a reference angle or your unit circle, whichever is available at this time. Our objective is to make sure we're practicing and you know how to read your unit circles. That's where we should start from at this point. Okay, so again, please pause the video at any point right now so you can try things out first. Okay, so using a 270-degree measurement, we're going to find the angle, the reference angle. In this case, it appears that you don't need a reference angle because it's exactly on this point right here. Let's find sine of 270 degrees, and according to us, if this is the coordinate point, sine will be -1, the y value, where cosine will be 0, the x value, and for tangent, if you were to divide -1 over 0, okay, you cannot, so we say that value is actually undefined, and that's okay. That is an actual valid answer. Okay, so the tangent theta or tangent of 270-degree measure is undefined. All right, in the meantime, for the second example, 11 pi over 6, remember, over 6 means half of a circle was divided into 6 parts, therefore the whole thing is into 12 parts. If that's the case, the 11th measurement would end up somewhere down here on this quadrant, on the 4th quadrant, if you notice. All right, so if we were that close to 12 pi, a full rotation is 12 pi, how far away are we from 11 pi over 6 to 12 pi? You're right, it's actually pi over 6, and that's the reference angle. But it is in quadrant 4, so you need to take note of the signs. All right, so pi over 6. Take a look at here. I placed this to guide you. So pi over 6, let's start with the sine value. The sine value is 1/2, that's the y value. However, because you are in quadrant 4, should the y value be positive or negative? You're right, it should be negative. On the other hand, when we talk about cosine, √3/2, the x-coordinate, should this be positive or negative? Again, you're right, it should be a positive measurement because it's an x value. And on the other hand, to find tangent, you must divide these two values respectively, okay, doing the following. So -1/2 divided by √3/2, where simplifying means you need to find the reciprocal of the denominator and multiply it by the numerator. When we did, we ended up finding -1 over √3, which in the past lesson you told me was not okay. We had to do this special procedure, rationalizing, in order to simplify the expression. And so really your final tangent measurement for 11 pi over 6 must be -√3/3. Okay? All right, so please avoid decimals. You don't want to see decimals right now. You want to just continue making sure you're simplifying the fractions that we have. Okay? And on the very last note, you can also evaluate for a negative degree or negative angle measure, this time in -30 degrees. All right, because it's a negative rotation, we're actually going clockwise. All right, so going down here, obviously your reference angle will be 30 degrees right here, or pi over 6. Okay, but now you're in quadrant 4, so think about this. In quadrant 4, should your sine value be positive or negative? Correct, it should be a negative value. How about your cosine? Should it be positive or negative? Think about it. It should actually be positive. All right, awesome. And of course, tangent is once again, for you to divide the y value and the x value, or the sine value over the cosine value. And if that's the case, we will go through the same process, exactly like what you did in the previous problem, okay, where we end up with negative root 3 over 3. So class, right now, with this lesson, you connected your angles of rotation to the trigonometric ratio of special right triangles that we worked on in the past. You were able to convert the measures of the angles from degrees to radians and back and forth. You were also able to identify and evaluate the functions based on the unit circle. And right now, you just completed using a reference angle to help you identify a few trigonometric functions. All right, so we'll stop for now. I'll see you soon. Bye.